Growing up, we've been taught that all snowflakes are immaculate six-sided shapes, but our average snowflake looks a little bit more like this. This photo is one of thousands taken by the multi-angle snowflake camera, and the way that we went from this to this is crucial to understanding weather forecasting and avalanche prevention. A majority of snow forecasting is based on only a handful of images from the 70s. Scientists from the University of Washington photographed snowflakes and measured their masses and fall speeds. Their only mistake? They took pictures after the snowflakes had already landed.
Now here's the problem with doing that. One is that when a snowflake lands on the surface, it tends to change its shape, and we don't want that to happen because we are interested in what the snowflakes are like when they are in the atmosphere. And then the other thing is that when we take pictures of snowflakes, we tend to pick out the pictures that are easy to photograph, and those tend to be the flat snowflakes because those are easy to get the depth of focus to match what our camera can take a picture of.
To solve this issue, a team of scientists from Salt Lake City developed a camera capable of capturing snowflakes in mid-flight.
What's going on now is the mask right there, that big black box, is the multi-angle snowflake camera, and it's taking pictures of snowflakes as they fall. You might be able to see the cameras flashing. Each time it flashes, that's one snowflake that it's taking a picture of.
When a snowflake falls through the aperture, motion sensors trigger cameras to take a high-speed picture. Then, the hot plate measures the snowflake's mass, and the thermal camera measures their temperature. Data is then interpreted from these instruments into visual models scientists can use to predict avalanches.
This is on the hot plate.
Okay.
This is our plate on the surface actually. This is in the air. Of course you can see due to turbulence actually all rotation, swirling, everything.
By assessing the densities of different layers of snow, these researchers have discovered a way to anticipate avalanche risk in real time. When hard-packed snow forms over a layer of soft, loose snow, interference can cause the top layer to slide.
People have measured the density, but you have to go and be present physically, and then you have to measure the density.
Well, our camera system sees snowflakes as they actually are in the wild. They see snowflakes as they are falling in the sky, whatever their orientation is, whatever their shape is, and it doesn't care whether they are flat or thin or whatever it is, it just takes a picture automatically of everything that's out there. And that forces us to be objective about what snowflakes actually look like. And what it's revealing is that snowflakes are much more complicated, varied, almost crazy shapes than we had previously imagined. And that's a huge advantage over what was previously available.
Studying snowflakes seems like an almost whimsical problem, but it could have very important implications for people's lives. However, although we have learned a lot about snowflakes, these measurements all come from one place, so there is still much more to be discovered. Seeking to understand the true nature of snowflakes is only the beginning in mitigating avalanches.